chapter is going to be dealing with logs. Okay, we kind of got introduced into logs in the last section, 5.3. We talked about some of the log rules that we could use and how to simplify and evaluate logs. Today, we're going to get into the log properties. And there's several of these. Some are going to be used a lot more than others, and I'll kind of go through that when we talk about it. And when we talk about logs, remember there's two different logs that we could see. We could see log, which is what we call our common log, and then we could see ln. And so all these properties that we talk about today can be applied to either one of those logs. So it doesn't matter what type of log we have. Okay, we can apply all these rules. And so I won't do all of these rules with both types of logs, but just keep in mind they work for both. Okay, so the first one is what we call the product rule. Okay, and we call it the product rule because initially we are multiplying two things together. A product. When I multiply two things together, the result is a product. And what we're going to do is we're going to separate them. Okay, and when we separate them, in order to separate them, they have to be the same base. And if they're the same base, okay, then we just take the two numbers that were multiplied together and put it with the log. And this is the general rule, right? I'm going to kind of show you an example here with numbers, and that'll make a little bit more sense probably of what's going on here. But we won't always see it with numbers. We'll see it with variables. Now, what I'll tell you is we're going to go both directions with it. It's kind of like we did with the log loop. Sometimes we went from exponential to the log. Sometimes we went from log back to exponential. Here, we will go from a single log to an expanded log with multiple logs in it. Or I will give you this expression and I will say write it as a single log. So once again, we're going to be doing a lot of going back and forth from one to the other. And the directions will simply say rewrite as a single log if it's given to us as this, or expand in log form. And so you're going to write it as more of an expanded expression. So an example here would be and they may already have the number multiplied together, whatever 9 times 27 is. They might just give us whatever that product would be. But I'm writing it now as a product of two numbers, 9 times 27. And we have two numbers here, so we are going to separate it. And we keep the log base 3 on both of them. And I put the 9 here and 27 here. It really doesn't matter which one goes where, but I'll just put the 9 first because it came first in the product. Okay. We could put this into our calculator, okay? And we can also put this into our calculator separately. And we talked about both of those a little bit last week. Well, this one right here, log 9 base 3, is really saying 3 to what power gets me back to 9. So I picked one out here that gives us some nice whole number or integers. Log 9 base 3 is 2. Log 27 base 3 is 3. Okay? And if I added those two together, I would get 5. Okay? If I put this into my calculator all by itself, and I did the log of 9 times 27, make sure you keep it in parentheses, base 3, then it would give me 5. Both of those sides should become equal to each other. So just trying to show you an example with numbers. I think numbers probably make more sense to us a lot of times. Just kind of seeing how it works. Okay. So that's the first one. That's what we call the product rule. The second one is what we call the quotient rule. and it's really just the opposite of what we just did. If I have the log of some base, and then I divide two things. Well, when I divide two things, the answer I get is a quotient. So that's why we call this a quotient rule. When I separate this, we're going to get the log of m base a minus the log of m base a. So on the product rule, when we multiply it, there's nothing between the m and n. We know that's assumed to be multiplication. When I separate, I'm going to put a plus sign in between. Here, if I'm dividing the two numbers or expressions, then when I separate them, I'm going to do subtraction in between. And I'm not going to show you an example with numbers on all of these, but we could put numbers in there. Once again, all of these are going to be things that we're going to, and I'll give you some examples where I give you the log and we expand it, or if I give you the expanded form, we write it as a single log, and we'll go back and forth a little bit today, kind of like we did when we talked about logs originally with exponential and logs. Okay, the third big one, and I would call these the three big rules. There's two others that I'm going to show you that probably aren't used as much, but we'll at least talk about them so we've seen them. But these three right here are the three biggest ones. And where we're going to use these as we go forward is obviously we're going to use them a lot today because that's kind of the topic for today. But then like tomorrow, what we're going to start to do is we're going to start to solve log expressions and log equations. And we're going to use a lot of these rules and properties to go back and forth and use them to help us solve in some of the situations that we have. So the power rule. When I think of a power, I think of taking something and raising it to a power, or I simply have an exponent. So here I'm taking m and raising it to the p power. What we can always do with that exponent is we can jump that exponent over in front of the log. And then I could rewrite this as p times log m base a. Sometimes they'll give us a number in front of a log, and I can jump it over and put it as the exponent. Okay, so once again, it could go both ways. Okay, if I did the log of 10 squared, that 10 squared is really 100, right? So here my answer would be 2. Or I could move the 2 out in front, and I could say 2 times the log of 10. The log of 10 is really 1. You can either put it in the calculator, or you could just remember 10 to what power gets me back to 10, which would be 1, and then 2 times 1 would give me 2. So in both cases, my answer here would be 2. Whether the 2 is in the exponent or it's out in front of the log. Okay, so those are the three big ones. We're going to use those a lot. As we go throughout, we'll see it some tomorrow when we start solving some equations. But we just kind of have to know how to go back and forth with those two. Okay, the other two rules or properties that we talk about here, these are a little bit less used. So I kind of put these by themselves. We may see it, so I want you to have at least seen it and be able to identify it. If we were to see something like this, but we probably won't see it quite as much. And this kind of goes back to our rule again, right? If I said a raised to what power, if I put my little box over here like we did last week, and said a to what power gets me a to the x, what would that entire expression equal? What do you think? What would I want to put into that box? If I said a to what power is a to the x? What would go into that box? Just x, right? I could just put x into this box. And so what this rule is basically saying, if these two bases are the same, my answer is whatever the exponent is. Okay? And that's all we would have to do. I could do it with numbers. I could say the log base 2 of 2 to the 7th, and that would equal 7. So that whole thing just equals a nice, easy number. Okay? So that's one just kind of, it really just uses our log loop that we talked about last week and kind of remembered some of the basics of that. The last one, and this one's kind of a weird one, but I want you to at least see it. And I say that it's weird because we're going to have a log in the exponent. And that's kind of a different scenario. So if I said a raised to the log x base a, and I want to know what does this equal? Well, if I rewrite this, right now it's in exponential form, right? And I want to figure out what is going to go in this box, kind of like we did last week when we did the log loop. What would be my exponent? Or what would this whole expression be equal to? I could rewrite this as a log expression. Right now it's an exponential expression, right? And so I'm going to start with log. Okay? The base of the exponent is base a. The exponent is log x base a, and what we're trying to figure out is what's going to go in this box right here. So to make these two sides equivalent to one another, this side right here is log x base a. This is log something base a. So what would need to go into that box? X. So x goes here, so x would go here. Okay. When we did it last week, it kind of looked like this. It's easier when it's numbers, right? And then I could say log base 2, exponent is 3 of a, right? This is what we did last week when we went from exponential to log. So we're doing the same thing here, but what makes that a little bit weird is that we're doing it with all variables, no numbers, okay? But here's the deal, okay? Kind of like the one we talked about up above. If these two bases are the same, the base of the exponent and the base of the log are the same, and that's kind of what we talked about on the last one, then my answer is whatever we're taking the log of, okay? And so that's where these two kind of tie together, is they have the same base, right? Base of the log and the base of the exponent are the same, so my answer is, in this case, whatever we take the log of. Okay, so those are our 5 properties for today. And we're going to see those in a lot of different scenarios. And so I'm going to give you some examples here of what we can, what you're going to see on your homework. And your homework today is going to be a little bit weird, okay? Because it's not going to be like, just like evaluate, or we're going to get an answer of like 3. Tomorrow we're going to solve equations, but today is going to be kind of the step up of how we're going to get to some of those problems tomorrow. So today we're either going to expand the expression or we're going to write it as a single log, depending on how it's written out. So the first set of directions I'm going to put up here is I'm going to say write as a single log. And I'm going to give you some examples where we're going to write this as a single log. Okay, when I gave you all the properties, all I did was use log. But what I said at the very beginning was, no matter what base or what log we have, I can use the properties the same way. So in this case, we have an ln. What's happening with a and b? What are we doing with the a and the b? We're multiplying it. Okay, so this is our product rule. And so when I rewrite this, I'm going to say the ln of a plus the ln of b. When we separate it, and I said right as a single log, but I gave you the single log to begin with. So we're going to actually expand it. I should have said let's expand. Okay, those would be your two directions. So I said it the wrong way. I gave you the single log, and we're going to expand it. Okay, another one. Really what we're looking at is what's happening here with what we're taking the log of. Okay, it's either going to be multiplication, it's going to be division, or in this case it's a power. If it's a power, we're going to take this power and we're going to move it over in front of the log. Okay. And that's really why today's homework is going to be kind of weird, is because you're going to wonder, am I done, right? But we just want to simplify it as much as we can. We want to rewrite the expression in another format, and that's it. Okay? So in that case, all we had to do is move the 4 over in front, and we're done. Okay, this one's a little bit different. We talked about this a little bit last week. And whenever we see a square root, okay, and what I just told you was either today we're going to have a product, we're going to have a quotient, or we're going to have a power. Well, in this case, we have none of the three. We have a square root, right? We don't have a square root property. So I want to rewrite this as either a product or a quotient or a power. Well, I can't write the square root of a as either a product or a quotient, but I can write it as a power. When I have the square root of a, the square root is same as taking something to the 1/2 power. If I have the square root of 9, I get 3. If I take 9 and raise it to the 1/2 power, I also get 3. Okay? So those two things give me the same thing. They're the same rule. One uses the square root, one uses an exponent. Okay? But they're the same rule. So the reason we do this is because now we have a power, and I can apply one of those rules that we just did today. So once again, I'm going to take the exponent that we have, I'm going to move it over in front, and I'm going to say 1/2 times the ln of a. And that would be our answer. Okay, this one is the log of 76 over 13 base A. Notice on these here, if there was a base A, I want to keep that base A here. There was no base on the ln, and so our base is assumed to be E on ln. I don't really need to put the E there because it's going to stay assumed to be base E. If we have a different base included, we want to put that base when we rewrite our answer. Like on this one here, because we had base A, we want to keep this one as base A. If I don't put that A there, then it means that it's going to be an assumed 10 if it's an LOG. So in this case here, we have a base A. When I rewrite it, I want to include that base A in my answer. Because we're dividing 76 by 13, I'm going to do the log of 76 base A minus the log of 13 base A. Okay, and we have a feeling we want to do more, right? And especially on this one because we have numbers. This is it. We don't know what A is, so we can't do anything here. If I don't know what my base is here, there's no way for us to simplify this. All we're doing today is just rewriting the expression. Okay, this one's a little bit more detailed. Because we got all kinds of things going on here. We're multiplying the x squared and the y together. We're dividing it by b cubed. So we're going to use all of that information and we're going to rewrite this. And we're going to separate each term. We're going to separate the x, the y, and the b into three separate expressions, three separate logs. The other thing that we want to do here is make sure that we keep base b on our log. Our base can be anything we want it to be, but if b is what we're given at the beginning, all of these have to stay base b. Okay, so the first thing we're going to do is log of x squared base b plus the log of y base b. Because the first two things on top, we were multiplying them together. So when we separate them, we're going to add the two expressions. Some people like to put these in parentheses just because they're tied together. On this one, you wouldn't necessarily have to put them in parentheses, but in some cases, there might be some situations where you might want to do that just to kind of keep those together. Minus, because we're dividing by b cubed, then I would say the log of b cubed base b. Okay, now, I think this is kind of the hard part, is how do we know when we're done? And that's why these are a little bit different today. Is there anything else we can do? Well, there's a couple more things that we could do here. We have an exponent here. Okay, this exponent, because there's an exponent, can jump in front of the log. And so I could rewrite this as 2 log x base b plus log y base b. Once again, if you want to keep that in parentheses, you can. I wouldn't count it wrong if you didn't, but I kind of like to keep those together. And then this one kind of goes back to last week as well. If I wanted to simplify this, and we actually just talked about this a few minutes ago, because my base is the same here, base b, my answer or my expression just becomes 3. Because remember what we talked about. B to what power gets me b cubed? So this whole thing becomes 3. So if you can simplify it, simplify it. If the two bases here were not the same, then there wouldn't be anything we could do. But because they're both base b, then it just becomes your exponent. And that would be our answer. Thank you, Mr. Fracking. All right, let's go the other direction. So all of those were expanding. I wrote the directions wrong at the beginning, but we started with a single log. We were expanding it and writing it as multiple logs. Okay, this last couple that we're going to do, I'm going to give you the expanded form, and we're going to rewrite it as a single log. So now I would say write as a single log. Okay, so they're going to give us an operation between two separate logs. In this case, once again, we don't have a base, so our base is assumed to be 10, right? Now I'm going to put these two together. So I'm going to go from multiple logs into a single log, and when I put these two together, what are we going to do with a and b? Because we have a plus sign in between. We're just going to multiply them. So we just write it as log of ab. That's it, and that would be our answer. Now I'm going to give you one very similar here. And this one's just a little bit different because we have some numbers involved. Okay, so we got a plus sign in between. We're going to take 0.01, or 1/100th, times 1,000. So if I take 0.01 times 1,000, what does that give me? What'd you get? 10? Okay. Now, let's think about what's going on here. And that's why this one's just a little bit different. A lot of people would stop right here. If you have numbers or variables, then there's not much else we can do. But because we have numbers, we're going to ask ourselves, can I simplify this some more? What's our base here assumed to be? 10, right? So if I have log 10 base 10, what's that really equivalent to? 1. So this whole thing becomes 1. That would be a little bit simpler. Can't do that on every single problem. Because like, let's say I did one like this. The ln of 54 minus the ln of 6. This time we have a minus sign in between. So if we have a minus sign, we're going to divide those two. If I can divide them, I'm going to go ahead and divide them. And so here it becomes the ln of 9. What's the base assumed to be on ln? E. Okay? So is e to some power going to get me back to 9? Is there any nice whole number that's going to make that work? No. And we could evaluate this. We could come up with a decimal answer that is equivalent to the ln of 9, but that's not really what we're doing today. We're leaving our answer as a log expression, right, as a single log, unless we can simplify it down to a nice whole number like we did here. Okay, last one here, and then I'm going to go through, I have one other problem I want to talk about that's a little bit different. Okay, so a little bit more involved here, a little bit more going on. We have some numbers in front of the logs, okay? So what we can do with both of these numbers in front of the logs is we can go the opposite direction. If it was an exponent, we would jump it over. If it's in front, we jump it over as an exponent. So both of these numbers are going to jump over and be an exponent on my two variables. So I'm going to rewrite this as log of x to the 2/5 base a minus the log of y to the 1/3 base a. Okay, remember the directions here. We're going to try to write this as a single log. So right now I still have two logs, right? So we're going to try to put these two together, simplify it. Because we have a minus sign in between, we're going to divide those two expressions. Now, here's probably the biggest mistake most people make, is they try to do the log of x to the 2/5 divided by the log of y to the 1/3. We're writing it as one log. So I just put a log out in front, and we take x to the 2/5 divided by y to the 1/3, and then don't forget to put your base a down there. Okay, if you don't put this base a here, then it's not completely correct, right? Because this is assumed to be 10, and we don't know if our base is 10. So we do need to include the base if there's a base in the problem. The only way I can do all of this work is if my bases are the same. If this one had base A and this one had base B, then we can't do anything here. Bases must be the same, but then we have to keep that base the same throughout. We can't change it or leave it out. All right, the last one I'm going to do with you here. It's the same idea, but it's an evaluation problem, and you're going to have one like this on your assignment today as well. this is number 64 from your book. And you can look at it if you want, but you don't necessarily have to. I'll write out everything you need to know here. 64 says the log of 14 base A. And they want us to evaluate that, okay? In the directions, they give us 3 different values. So they say that the log of 2 base A is about 0.431. The log of 7 base A is about 1.209. And then they also give me the log of 11 base A is about 1.490. So they give me 3 different expressions at the beginning in our instructions, okay? And what we really want to kind of figure out is how can I use these 3 to somehow get to 14? And you may not need all 3, right? So is there any combination that I can use of 2, 7, and 11 to get to 14? And remember, we got 3 things that we can basically do. We can use product, quotient, or powers. So is there anything in that original set, 2, 7, and 11, that we can use to get to 14? Yeah. 2 times 7 is 14, right? And so I can rewrite this base A, right? And by rewriting this, now because we're multiplying the 2 and the 7 together, we can separate these 2. And I could say the log of 2 base A plus the log of 7 base A. And the reason we do that now is because we don't know what the base is, we wouldn't be able to put this into our calculator. So this is not going to be a calculator problem until we get to the very end here probably, where the log of 2 base A is approximately 0.431. So we would put 0.431 in here. And then the log of 7 base A is about 1.209. And I would add those 2 together. And we get about 1.64. And that would be our answer. So we're just using the information that was given to us and somehow putting that together to get where we need to be. Okay? And trying to evaluate what it is. But we can't just put this into the calculator like we did last week because we don't know what the base is. The base could be anything. But right now it's a variable. Okay, assignment for today. Okay, and the biggest thing here is just make sure that you pay attention to the directions today. Hardest part is knowing when I'm done and when I'm not done today. And we're just doing a lot of changing it back and forth, one to the other. And then the very last one is like what we just did. I did number 64, I think, with you. Number 63 it's using the same numbers. It's the same set of problems. You're just doing a little bit different situation.